Okay, here we have a differentiation problem. Find dy dx. Just differentiate the normal way to begin with part A. So we've got 3 times a third, which is 1. Drop the power by 1 to get x squared. And the minus 9x becomes minus 9. And the 1 disappears. And that's it. Part B. Find a range of values of x for which c has negative gradient. So c is just a curve. Negative gradient. This is the phrase we need to zone in on or zoom in on. And think, what does that mean algebraically? Well, gradient. Is there an expression we have for gradient? Yes, there it is. And negative less than 0. So negative dy dx is what we need. And that means dy dx just has to be less than 0. Substitute our expression that we found in part A, and then just solve that inequality. You can use your class whiz to solve that, but it's good to know how to do it. It's very tempting, isn't it, to move the minus 9 to the other side and get 9 here. But actually, it's not a good thing to do that, because it's then tempting to square root and get x is less than 3, but then that's not the correct way to solve quadratic inequalities. The correct way to solve quadratic inequalities is to factorise, and this is a difference of 2 squares expression, which factorises like so. We can then read this as we have a quadratic curve with roots minus 3 and 3, and it's under the axis. So draw the curve with roots minus 3 and 3, and we're interested in the x values where the curve is below the axis, and that's clearly this range of values between minus 3 and 3. And that's our answer. X is between minus 3 and 3.